You had to do at activity 2, which one? Yeah, but which numbers that I give you? I know the outside. A. Okay. Um, the first ones, A, B, D. I just wrote down the answer. I'm just quickly going to show you here. The reason I only wrote down the answer is because there was nothing to it. Right, do you agree with that? So the theorem says if there's an angle created by the same chord or arc at the center, that same arc or chord subtends an angle at the circumference, then the one in the center will be double the size the one at the circumference. Therefore, it was very easy. The first one, x is 30 degrees, and your reason will be angle at the center equal to 2 times angle at the circumference. I'll just quickly write the English here. We say angle at center equal to 2 times angle at circumference. Okay, the next one. Now they gave you the circumference angle and you wanted the center angle. So now you just had to remember the one in the center is the bigger one. So you had to double 24, therefore it's going to be 28, and it's the same reason. Angle at the center equal to 2 times angle at the circumference. Did you have to do D? Okay. If you look at D, do you see A and B? They subtend that angle in the center. And A and B also subtends the angle C, which is on the circumference. So it's also an angle at the center, angle at the circumference, and therefore x is 18 for the same reason. E. Did you struggle a bit with E? I hope you didn't. You see, the 2 points subtending C is A and B. There it is. Do you see it? And A and B also subtends this big angle here. That angle is a reflex angle. So if I use the rule, the theorem, angle at the center is 2 times angle at the circumference, it would mean this angle is 240. And doesn't that make sense when you look at the size of the angle? It's reflex, it's greater than 180 degrees. So therefore it makes perfectly good sense. X is equal to 240, angle at the center equal to 2 times angle at the circumference. And then I. Alright, the first one there, it was given that that Q angle is 70 degrees. You have to find X and Y. Now, do you all notice that X is part of a triangle OPQ? And Y is part of a triangle RPQ. Now, in Y's triangle, do you also see that you don't have any information? Because this 70 degrees is not one of the angles in that triangle. But in X's triangle, I have one of the angles. I have that angle as 70. Is there another angle that I can find? Which one? What is P going to be? Y. It's isosceles. You're going to say isosceles, and then you must please also say radii, because you know they didn't tell you it's an isosceles triangle, né? It's your knowledge that made you see it's radii and isosceles, yeah. let me just speak up a bit the reason. Yeah, and then you said radii, and then you said isosceles. That's perfect. Something else, another reason that you can use that they also want you to use is to say, you've got isosceles radii there, or is to say angles. Let me just get the right way. It's not opposite. I will confirm that one with you. Just give me a second to think about it. But it says like when you've got equal sides, equal angles. I think that's all it says. Equal sides, equal angles. Equal angles, equal sides. Okay, but I will confirm that one with you. But you all see it, you understand why that one is 70? Okay, now I can find x, right? It's going to be 40, and my reason will be sum of the triangle. And once I have x, I can now find y, ne? Because x is the angle at the center, and y is the angle at the circumference. So y is going to be 20, angle at the center equal to 2 times angle at circumference. Do you understand? Everyone happy with that? It was just up to there that you had to do it, no? Alright, can I just quickly ask you to look here at J with me? I just want to show you that they like bringing in the parallel lines. And they do it a lot. And then you must remember the fun functions. So if you look at this thing, do you see there can't be any corresponding angles? Because when there's corresponding angles, one of these sides had to be extended. Do you agree with me? To make the F. There can't be a U because it's not closed. You can't have co-interior. The only one you can have is alternate. Okay. So that would mean that angle is 20, right? With alternate. And do you see that's the angle at the center? So what is the angle at the circumference? 10. That one is going to be 10. Does that make sense? Okay. So just want you to remember that. There was a sum that I did with the Afrikaans class. We got a bit further yesterday. And that is going to be question at exercise 1, question D. I want you to look at it with me. Okay. Just look at this sketch. So what they tell you is that AB is a chord. And they say O is a center, and OE bisects AB. So, what does that tell me? There's a 90-degree, no? It's theorem 1. So, I see the triangle there. I see sides. Sides I can only find with Pythagoras or with congruency. The rest is about angles. Okay. So if I want to do Pythagoras, I need a 90-degree angle. So the first thing I would do is say that those two lines are perpendicular, because the line from the center bisects the chord. Right. Once I have that angle of 90 degrees, they are asking me to find the radius OB, OB in terms of x. Okay. Now look at this. I did it here. I just want to show you. You would say OA or OB, it's the same radius. OB squared is going to be equal to 12 squared plus x squared. Do you understand what I did? The 12 was given, the x was given. When they tell you that the answer must be in terms of x, that means you're not going to get the answer. It's still going to have an x in it. Right? So all I can do from there on is to take the square over and make it a square root. And then I'm done. I can't do anything else. That's the answer in terms of x. Do you understand that? Then the next question asks you to hence solve, to calculate the length of the radius. So that OA I got was the square root of 144 plus x squared. Do you agree with me? OE is also a radius. And that OE is x plus 8. And the two of them are equal to each other. So what we do is we let the two be equal to each other. I want to show you the calculation. So we let them be equal to each other. Square both sides to get rid of the square root. How do I square that? It's x squared, x times 8 times 2, 8 squared. This side it just disappears. Then it's x squared on both sides. They cancel out and I find x to be 5. Do you see how they can make it tricky? So you can maybe make a note there to go and have a look at exercise 1D. I haven't really noticed that they ask it in this difficult way, but it's good to go and have a look at that and understand it. Right, now you can open. Yeah? Okay, we finished with example 1 yesterday. Did I ask you to do example 2 or not? Okay, let's quickly do it. We have to find this angle y. Now, do you remember we also did the third theorem yesterday where we saw angle in a semicircle? Do you remember that one? But we're going to pretend we don't know that one yet. We haven't learned about it. So we're only going to use angle at the center, angle at the circumference, and all of the previous theorems that we've learned in the lower grades. So I see that that is the angle at the circumference. Can you see that? And it is being subtended by AC. And AC also subtends another angle. This one, I'm just going to call it A so you know which one I'm referring to. It also subtends A, which is the angle at the center. Now, if I couldn't find a way to find A, that would mean that I have Y. Do you agree with that? Can you think of a way to find angle A? What can we do? I hear isosceles. Is that what I heard? No? I've got radii. You all see the radii. Whenever you've got an angle at the center, you must be on the lookout for angle at the center, angle at the circumference. And you must be on the lookout for an isosceles triangle. Because if there's an angle at the center, that angle must have been made by a line or two lines that started at the center. So it might be radii if they're going down to the circumference. So that would mean this angle is 35 degrees. Do you agree? So let's say angle C equal to 35 degrees. You can just say radii and isosceles. So now I can find A. That A is going to be what? How do you get to 110? It's the sum of the interior angles. No? And now that I have that angle A, what is Y going to be? Y 55. Angle at the center is 2 times the angle at the circumference. Well done. Do you understand that? Okay. Okay, can we just very quickly go through Theorem 3, the angle in a semicircle? I've got a triangle there, I've got one known angle, and I want to find the value of x. I need the value of c. What's the value of c? 90. C is 90 degrees, and my reason is angle in a semicircle. And once I have that angle, I know that x is equal to 30 degrees. Sum of a triangle. Do you understand, everyone? Nothing funny there? Can you quickly tell me what the size of x is going to be in the next one? Who wants to try? 40? 48, right. So we're going to say PRQ is equal to 90 degrees. The reason is angle in a semicircle, and therefore we can say x is equal to 48. Okay, are you good? You understand that? So, to just very quickly summarize the three midpoint theorems, the first one is a line from the midpoint that bisects the chord will be perpendicular. And the line that's from the center that's perpendicular on the chord will bisect the chord. First one. Second one, angle at the center is going to be 2 times the size of the angle at the circumference. And the third one is angle in a semicircle is equal to 90 degrees. Happy? Good. Next up, we've got the three cyclic quadrilateral theorems. Okay, so I told you a cyclic quad is when you have a quadrilateral that the four vertices lie on the circumference of the circle. But I also told you that it doesn't even necessarily have to be a closed quadrilateral. When I've got 4 dots, the 4 dots are on the circle, on the circumference, then that will mean that you do have a cyclic quad. Do you understand that? Okay. Now the first theorem, I'm just going to show you the proof here quickly. If I have a center there, and that angle is 100, and I have an angle there at the circumference, you know this one, right? What's that angle going to be? 50 degrees. Because the angle at the center is 2 times the angle at the circumference. Now if I take this same chord or arc, AB, and I make an angle there, what's that angle going to be? Also 50, because it's also an angle at the center and an angle at the circumference. And what if I make another angle there at the circumference? What will that one be? 50. Because it's another angle at the center and angle at circumference. And another one there, that one's also going to be 50 degrees. So do you see what we are getting to? When we have angles on the circumference, and they are all subtended by the same chord or arc, they will be equal. So do you remember we said yesterday, if I have mom and dad A and B, if they have an angle at the center, it's double the angle at the circumference. If the one child is in the middle and the other is at the end, the middle one will be double the end one. But if they have different children, all on the circumference, all of those children will be the same. Okay, so equal chords that subtend equal angles. That's theorem number 1. Do you understand that? Okay, we're going to do examples now. The second one is that when you have a cyclic quad, let's call it A, B, C, and D, the theorem says that the opposite angles of a cyclic quad will be supplementary. Do you know what supplementary means? 180 degrees. So let me show you the theorem. I would do a construction there. I would put in dotted lines. And let's say we call this one O1 and this one O2. Do you agree O2 is subtended by AC? And AC also subtends B. So this one is going to be 2 times B. No? O1 is subtended by AC on this side. And AC also subtends D on this side. So they are not next to each other, they are on the outside. Then it's angle at the center, angle at the circumference. There must be a line between them. No? So this one is going to be double that one, so it's going to be 2D. Are you still following? Okay. And what is the size, or what do we know about those two angles together, O1 and 2? 360. So look, O1 was 2D, O2 was 2B, and together they give me 360. How do I get rid of those 2's? I divide by 2, and then I have D plus B is 180 degrees. So that will always be the case. The opposite angles of a cyclic quad, they're supplementary, they add up to 1. And then the last one is so easy, and it's also a theorem whose proof they don't ever ask it. If I have a cyclic quad here, and I have one of the lines extended, in other words, in a straight line. Do you remember what we call that? An exterior angle. No? So I want to see what is the relationship between the exterior angle and whatever I have in there. So if I had this angle and it was 100 degrees, no? What would that angle be? What would this angle be? The opposite angle. 80 degrees. No? Because do you remember we just said they are supplementary. So this angle will be 80 degrees. Are you happy with that? Okay. And these two angles are adjacent on a straight line. No? Okay. So what will that angle be? 100. So that brings us to the theorem of the exterior angle of a cyclic quad. That the exterior angle will be equal to the opposite interior angle. The reason for that is these two are supplementary and these two are also supplementary. So those two must be the same. That's the 3 cyclic quad theorems. So equal chords subtend equal angles, opposite angles supplementary, exterior angle equal to the opposite interior angle. All happy with that? Okay. A cyclic quad is what? Let's get to these pages. Open there. A cyclic quad is 4 points on a circle's circumference. Right, let's just quickly read through this. Theorem 4 does not have to pass through the center. Very important. This has nothing to do with the center. Okay. The shape creates 4 points on the circle circumference and therefore is considered a cyclic quad theorem. Angles on the circumference of the circle that is suspended by the same chord or arc are equal. You can read the next one. It says that we can also use the converse. An example of that I want to show you here very quickly. Let's say I have a Pythagoras triangle. I tell you that angle is 90 degrees, this side is 4 and this side is 3, and I ask you to find that side. Then we can say, because of Pythagoras, this one squared plus this one squared must be that one squared, and then we can calculate this one to be 5. Because the 90 degrees was given, I could use Pythagoras. Do you understand? Okay. If it happens that I have this side as 4, I have this side as 5. Do you see it was not given that there's a 90-degree angle? Do you see that? So can I do Pythagoras? No, I can't. I can't do Pythagoras. But do you agree, because that side is 5 and this one is equal to that one, this side must also be 5. And because Pythagoras is working, I can do the converse of Pythagoras and say, therefore, that angle must be 90 degrees. Do you hear? Yeah, because it is 90 degrees, that one is going to be 5. Yeah, because that one is 5 through a different reason, this angle is 90 degrees. Kijk, jy moet staan waar jy trek kom. Papa gaan nou nie seconds om my op te staan. Ek sien jou daar. Moenie by die hek uitgaan, jy staan nou by Karolbo hulle. Ek gaan nou vir jou kom kyk, hoor? Do you understand? So if we have like a bow tie somewhere, and I can prove in any other way. Maybe let's say I'll have parallel lines. I tell you that one is 80 degrees, né? And I tell you that these two sides are equal. Then I can find that angle to be 80 because of alternate. Then I can find that angle to be 80 because of isosceles. And now do you see? These 2 points subtend the angle that's 80, and the same 2 points subtend another angle that's 80 as well. That means this is a cyclic quad. Although it's not, there's no circle, but it would fit into a circle perfectly. Do you understand that? Like if you think about a square fits inside of a circle perfectly. A rectangle fits inside of a circle perfectly. They are cyclic quads. Okay, because of its properties. Right, now let's do this first example. Tell me, what is C? What's the size of C? What? 50? Let's just quickly look. What are you saying? Because the angle at the center, ne? Okay. So if I take that point right there, ne? Is that in the middle? No, it's not at the middle. Can you all see that? I'm not going to be able to do it now. Okay, just put it here. I will do it.
And then you said all the pixels.
That's not in the center. Don't be stuck on the center theorems. There is no center in that circle, so you can't use one of the center theorems. But there are 4 points on the circumference. What do 4 points on the circumference mean? Cyclic quad. What do we have when we have a cyclic quad? We can have equal chords, subtend equal angles. Or we can, with the other name for it is angles in the same circle segment. Okay? Angles in the same circle segment. Or we can have a closed cyclic quad where we can find the opposite angles. Do I have a closed cyclic quad there? No, I don't. Or I can have an exterior angle of the cyclic quad. Is there an outside angle in that cyclic quad? No, so that leaves us with pretty much one option. Okay? So can you tell me which 2 points subtends C? Take your fingers on your page. There's C. K and M. Do you see? Does K and M have other children? In other words, is there another angle created by K and M? What? 24. So please tell me, what is the size of C? 24. C is equal to 24 degrees. Angles in same circle segment. Starten. Do you all see it? Okay. Now normally, when I would tell you to try to find D now, what most learners would do is they would say they take that 102 degrees and find the angle next to it. Ne? With adjacent angles on a straight line. So it will be 78 degrees. Do you see that, Katleo? Do you all see? Does that seem like a good plan? And then after you found that angle is 78, you would use 78, 24 and D for the sum of the interior angles, and then you would find the size of D, which works perfectly. But I promise you, you can ask anyone. The trick to grade 11 geometry, the trick question in all of the questions, 99% of the time, is exterior angle of a triangle. So, here it doesn't matter. It doesn't make a difference if you had to say adjacent and then sum. But we are going to get to questions where you're going to have to give the answer in terms of x. Then you cannot do that jump. So I want you to always, whenever you get a sum, I want you to look for an exterior angle. Maybe you won't even use it in that sum, but try to see the exterior angles of the triangle. So exterior angle is when one of the sides of the triangle is extended. Then an angle is created on the outside. Then that angle will be equal to the sum of the opposite interior angles. Does that make sense to you all? Do you see it there? It's not a new one, it's a familiar one. But because we can cheat it with adjacent and then sum of, most of us do that all of the time. Okay, so I don't want you to write down that one. I want you to say D is equal to 102. And here I just want you to write down the sum we're doing so that you see where we're getting it from. It's equal to 78 degrees, and my reason is exterior angle of a triangle. Are you happy with that? You all understand that? Okay, now before we do the second one, I just want to show you something. You know, we've now spoken about angles being subtended by the same chord, right? Or angles in the same circle segment. So what is y going to be? What is subtending that angle? H and G. What is H and G also subtending? The 22, so y is going to be 22. Do you see? EF, they subtend 18, and EF, they subtend X. Yeah? TS subtends 16, and Y, and X. All of them will be 16. Yeah? BC subtends the 32, and it also subtends X. It's also going to be 32. You're getting the hang of it, okay? But I want to show you that it is also true when the two chords are just given as equal. So if I were to lift this triangle, né, and reflect it and paste it on that one, do you agree it will be exactly the same? Because the chord is the same length. Even if I don't reflect it, if I just pick it up and I put it there, I will have the same distance there creating that angle, and the same distance there creating that angle. So it will once again be equal chords equal angles. Do you understand? Even if they're not in the same circle, but the circles are the same size, they will also subtend equal angles. So this chord is here, it subtends that angle. Let's say it's 50 degrees. If it's the same size circle and that chord has the same length, that angle will also be 50 degrees. Okay. Right, so that brings us to example 2. Calculate the size of x. Now, can you tell me what subtends x? DE. Does DE subtend anything else? No, it does not. But do you see there is something about DE? What is there about DE? It's equal to AB. What does AB subtend? It subtends C. So I know this is also x, right? They're both x. They're equal to each other. Does AB subtend anything else? What does it subtend? What is O? 120. It's an angle at the center. So what would that mean for that C angle there? 60. So I can say ACB is equal to 60 degrees. Angle at center equal to 2 times angle at circumference. And now because I have C, I know that x is also equal to 60 because it's equal chords, equal angles. Do you all understand that? Are you sure? Okay. So, what I asked the Afrikaans class to do is to do the next page. There are 3 examples where we're going to use the opposite angles of the cyclic quad. That's an easy one, eh? Very easy. And also the exterior angle will be equal to the opposite interior angle. So they are doing that, and then they are doing example 2 here. So this is one, and this is a challenge. We haven't spoken about this. We only briefly spoke about that when I showed you the bow tie. Okay, so this one is a converse. So they've given you information. This is a quadrilateral. Do you see the quadrilateral? They want to know, is it a cyclic quadrilateral? Right. So I'm not going to give you any hints. I want to see if any one of you can prove that this is a cyclic quad with what we have until today. Okay. I just want you to take note in the way the question is stated. When they say prove that this is a cyclic quad, they are saying it is a cyclic quad. You must just show that it is. Do you understand? When they say determine whether this is a cyclic quad, then it might be a cyclic quad, but it might also not be. It's not set in stone that it is or it isn't. You're going to have to go and see which way it's going. Don't lie. Okay? In geometry, you do many sins. You lie all the time. Don't lie. Don't assume. If it's not given and you haven't proven it with a reason, then you cannot use it. Doesn't matter what it looks like. Okay? So you can start with that now, and then you do this page for me for tomorrow. Tomorrow we're going to do the tangent theorems, and then we're done. Then we're going to start practicing the big problems. Okay.